Hello and welcome. I'm Josh Silverman, and this is Edge Ed, cutting edge education from coast to coast. Today's lesson 45, 45, 90 right triangles. Let's take a look. 45, 45, 90 is a topic in the Pythagorean theorem. And the first real insight that you need to have here is that when you see the words or see the figure of the diagonal of a square, diagonal of a square is code for 45, 45, 90 because a 45, 45, 90, aka an isosceles right triangle, is what you get when you cut a square in half along its diagonal. Of course, we know that all four sides of a square are the same. So this and this and this and this, they'll all be equal. We also know that all four angles are right angles, 90-degree angles. So when we take that and we cut it in half along the diagonal, here's what we get. We're going to get something where we've got two equal sides. We know this is a right angle. This used to be 90, and then we cut it in half, leaving us with 45. Used to be 90, we cut it in half, leaving us with 45. All right. Let's imagine that the original sides of this square were, I don't know, 4. Now, if the original sides of the square were each 4, what would be the length of each of these two sides? It'd be 4, because they used to be sides of the square. And the Pythagorean theorem tells us that a squared plus b squared equals c squared. The square of the two legs added up is equal to the square of the hypotenuse, the longest side. A squared plus b squared equals c squared. Let's solve for b. If we know that this is a 4 and we know that this is a 4, then this would be a 16 plus a 16, and 16 plus 16 is 32. 32 is equal to c squared. Take the square root of both sides. Now, if you're simplifying a radical like root 32, split that up. Split that up into root 16 times root 2. What is the square root of 16? 4. That's why I picked 16, because it's a perfect square. So this is going to equal 4 root 2, and C, the missing side is 4 root 2. When the legs of a 45, 45, 90 are both 4, the hypotenuse is equal to 4 root 2. Okay, but what if the square doesn't start with sides of 4? What if the sides are a different length? Maybe they're 10. Let's take a look. All right, this time our square's got sides of 10. So this is going to be 10, this is going to be 10, this is going to be 10, this is going to be 10. When we cut it in half along the diagonal, that wasn't a very good cut in half along the diagonal, but we'll survive. Then this would be 10, and this would be 10. We know that's a 90. We know that's a 45. We know that's a 45. Let's work that same technique. The two legs, we square them, we add them up. That would be a 10, that would be a 10. 10 squared is 100. 100 plus 100 is 200. What is the square root of 200? Well, take that root 200, split it up into two things. And the trick is, make the thing on the left a perfect square, something that you can nicely and neatly take the square root of. Like, how about 100? So this would be root 100 root 2. Root 200 is the same as root 100 root 2. And what is the square root of 100? It is 10. This would be 10 root 2. When the sides are 10, when the legs are 10, the hypotenuse is 10 root 2. So when the legs were 4, the hypotenuse was 4 root 2. When the legs are 10, the hypotenuse is 10 root 2. Do you see the pattern? Whatever the length of the legs is, the hypotenuse is equal to that times root 2. Let's look at the general formula right now. For all 45, 45, 90, for all isosceles right triangles, both sides are the same. Both angles are the same. This is a 90-degree angle. And whatever the legs are, that's going to match. And the hypotenuse is equal to leg times root 2. That's it for this session. Thanks so much. See you. Bye.